Hello there. We're going to go through this question, which you might pause and solve yourself. And the question is related to partial fractions, so expressing in terms of partial fractions and then obtaining an expansion of f of x in terms of some terms up to x squared. So express f of x in terms of partial fractions. We see that the degree of numerator is 2. The degree of denominator is 3, so there is no need for long division. Therefore, I write two fractions with those denominators. You can now pause a movie and try yourself. So after eliminating the denominators, I get this expression, which is true for any x. So I can take whatever x I want, and of course I'm going to act strategically, and I'll take x equals -2 to eliminate this term. So replacing x with -2 give me a value of a. Using this value of a, I will replace x by 0. Well, I would like to eliminate this term, but as it does not have real roots, I'll just take x equals 0, makes things simpler. So 6 equals a times 4 plus c times 2. And there I find c. After it, I take x equals 1. I could really take any x, and I find b. So here is the expression in partial fractions. Now I like to write it as write its expansion in ascending powers of x. In order to do this, I take each of those two fractions. So I take the first one, and of course I write it in the form a plus something to a power, so that I can use the formula. And in my case, n equals -1. Instead of x, I use 1 over 2x. And I write 1 plus n x, whatever is in terms of x, instead of x, plus n minus 1 over 2 something squared. And I get this expression. For the second fraction, I write it as x minus 1 times x squared minus 4 to the power of -1. I take a 4 in front so that I have 1 here, and I see that n equals -1, and instead of x, I'm going to use 1 over 4x squared. Right, so using its expansion and then multiply by x minus 1, I'm just looking at strategically at the terms containing x squared, so it makes no sense to multiply x by x to the power of 4, because I need up to x squared. So x squared comes from x times 1 over 4, from 1 times x squared, and that's it. And I obtain this expression. So therefore, this is the expression of the fraction using terms up to and including x squared. Now, of course, I would like to visualize what I've done. So the green function is the initial function. The red function is one written as partial fractions. The green and the red come one on the top of each other, so that's why you don't see them. It's one on the top of other, so the green and the red are exactly the same as expected. And now h of x is an approximation of f that you can see is very accurate for x within a certain domain. So for this x, it's a very accurate approximation, and I can use, for example, x equals 0 here to find a value of 3 over 4 for h instead of putting it here.